Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 24, Episode 56. Coming up on SpaceTime, Blue Origin to start sending tourists into space in July, unraveling the mysteries of ultra-luminous X-ray sources, and a new deep space dish for the new Norcia ground station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Blue Origin have announced that they're going to start sending people into space, including at least one space tourist, on July 20th. The date was chosen to mark the 52nd anniversary of the historic Apollo 11 moon landing. The 10-minute suborbital trip aboard New Shepard will mark the official start of regular space tourism operations, taking passengers beyond the 100-kilometre high Kármán line, the internationally recognised official start of space. So far, New Shepard successfully carried out 15 unmanned test flights from its launch pad in the Guadalupe Mountains in West Texas. Unlike its main competitor, Virgin Galactic, which launches and lands on a conventional runway, New Shepard, which is named after Alan Shepard, who 60 years ago became the first American in space, blasts off vertically from a traditional launch pad and tower. During the ascent, the capsule separates from the booster, with the momentum carrying it on into space, allowing tourists to get up to 4 minutes of weightlessness and spectacular views of the curvature of the Earth. After reaching apogee, the capsule then begins its return into the Earth's atmosphere, eventually deploying 3 large parachutes and floating to the ground. Meanwhile, the booster rocket itself autonomously returns to the surface, touching down vertically on a nearby landing pad. The reusable spacecraft's already being used for suborbital scientific payloads. And if you want to become one of the people payloads, you'll need deep pockets. A trip to the edge of space won't come cheap, with prices of around $250,000 per seat. And there are strict conditions of travel as well. You'll need to be between 60 and 193 centimetres tall and weigh between 50 and 101 kilograms. You'll also need to be able to dress yourself in a one-piece zip-up flight suit, climb the launch tower in less than 90 seconds, walk quickly over uneven surfaces, not be afraid of heights, I thought that would have been a given, not be claustrophobic, another given, be able to handle reasonably high Gs during the launch and descent phase of the mission, and be willing to sit strapped in your launch couch for up to 90 minutes. You'll also need to understand English and see and respond to alert lights that are displayed and be able to fasten and unfasten your seat harness in less than 15 seconds. But if you can do all that and you've got the money, you're now able to officially become an astronaut. This is SpaceTime. Still to come, trying to unravel the mystery of ultra-luminous X-ray sources and a new deep space communications dish for the Norcia ground station near Perth. All that and much more still to come on SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Okay, let's take a break from our show for a word from our new sponsor, NordVPN. like everyone, you want to protect your data and stay safe online. So you need to do what I do, and that is use NordVPN. NordVPN is simply the world's most advanced VPN service provider. They offer double data encryption and a strict no-logging policy. They're also rated #1 for speed and have access points in more than 60 countries around the globe, with more being added all the time. When you think about it, with all the threats and dangers in the cyber world today, you really do need to include a virtual private network as part of your digital security package. Whether it's for work or for your family's privacy, NordVPN will keep your data under wraps. And it will also allow you through those frustratingly geo-blocked sites, and it's all at affordable prices. Now, to get you started this week, we have a special offer. Not only will you be getting the world's most advanced VPN, but you'll also be helping to support SpaceTime. Just go to nordvpn.com/StuartGary or use the coupon code StuartGary to get a 2-year plan plus 1 additional month, all with a huge discount. That URL again is nordvpn.com/StuartGary or use the coupon code StuartGary at the checkout. And of course, you'll find the URL details in the show notes and on the SpaceTime website.
You're listening to SpaceTime with Stuart Gary.
A new study using the European Space Agency's XMM-Newton space telescope may be on track to solving the mystery of so-called ultra-luminous X-ray sources. These are mysterious objects, extremely bright X-ray point sources in the sky emitting more radiation than 1 million suns and are consistently far more luminous than any known stellar process. But at the same time, they're not sufficiently luminous to be an active galactic nuclei, or AGN, which are caused by feeding black holes. So their exact cause remains a mystery. Astronomers using the European Space Agency's XMM-Newton space telescope have discovered a quasi-periodic dipping in the X-ray light coming from an ultra-luminous X-ray source known as NGC 247 ULX1. NGC 247 ULX1 is a super soft ultraluminous X-ray source in an intermediate spiral galaxy known as NGC 247, located some 11.1 million light-years away. The cause of the change in intensity of this X-ray source is poorly understood. The authors observed NGC 247 ULX1 on 8 occasions using XMM-Newton, finding deep and frequent dips in the light curve on 1,000 and 10,000 second timescales. They also found that the amplitude of these dips increases at higher energies. The findings, reported on the pre-press physics website archive.org, could mean the dips are being caused by either the occultation of the central X-ray source by an optically thick structure, such as a warped accretion disk, or it could be obscured by a wind launched from the accretion disk, or it could be both. Both options support the hypothesis that super soft ultraluminous X-ray sources are seen from Earth close to edge-on to their accretion disk. The findings were made possible by observations carried out with the XMM-Newton Space Telescope. The X-ray Multi-Mirror Mission Space Telescope, or XMM-Newton, was launched back on December 10, 1999, aboard an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana. At the time, it was the largest scientific spacecraft built by the European Space Agency, and a pioneering satellite for studying the universe across different parts of the electromagnetic spectrum at once. Originally designed to operate for just 10 years, the 3,764-kilogram spacecraft has continued observing the universe and provided data for around 6,000 scientific papers. Newton circles the Earth in a geocentric orbit with a semi-major axis of almost 66,000 kilometers. Since its launch, it's studied over 500,000 X-ray sources, including supernovae, star-shredding black holes, and superdense neutron stars. X-rays allow scientists to probe things such as stars, the stellar debris of supernova remnants, and the extreme environments around black holes. But the high-energy light can't penetrate Earth's atmosphere, so this type of data needs to be collected from space. ESA designed XMM-Newton with 3 large co-aligned telescopes to capture as many X-rays as possible over a wide field of view, equivalent to the apparent size of the Moon as seen from Earth. The telescopes send the collected light to the spacecraft's instruments. These include the European Photon Imaging Camera, which was developed by a collaboration including the Max Planck Institute and the University of Leicestershire. It produces images that allow scientists to chart how the brightness of sources changes over time, in the process providing information about the target's temperatures and surroundings. Atoms in extreme environments around black holes and in stellar debris lose electrons, producing characteristic X-rays in the process. XMM-Newton's reflection grating spectrometer, developed by the Netherlands Institute of Space Research and Columbia University, can pick out signals from specific elements like oxygen, nitrogen, carbon and iron. Because cosmic events rarely if ever emit just one type of light, NASA's provided XMM-Newton with a matching optical and ultraviolet monitor telescope, which studies objects at visible and ultraviolet wavelengths, making XMM-Newton a multi-wavelength satellite. Previously, simultaneous X-rays, optical and ultraviolet measurements were only possible by coordinating observations between satellites and ground-based telescopes. But observing from the ground means dealing with cloud cover, and of course it's limited to nighttime operations. Combining multiple telescopes on a single space platform improves efficiency. Since its launch, scientists have used XMM-Newton to learn about neutron stars, the crash course of massive stars in the debris of the supernova explosions that created them. Newton detected the first sudden spin decrease seen on an accreting pulsar, a rapidly spinning neutron star powered by gas being funneled onto it from a stellar neighbour. X-rays also bounce all around the environments near black holes, creating echoes that act like sonar to map areas around supermassive black holes. XMM-Newton's also imaged the earliest moments of tidal disruptions, cataclysmic events that occur when stars are torn apart by black holes. And it's found some of the missing normal baryonic matter hidden in the intergalactic medium. Based on its current performance, Newton should remain operational until at least 2028, providing many more years of astronomical observations and discoveries. This report from NASA TV.
The longevity of XMM was not foreseen. It just kept right on going.
Something about looking at the night sky that just fills you with a sense of wonder, and I just never grew up from that.
XMM has been a part of my career from the earliest stages even until now.
XMM is a space-based observatory that studies X-ray light from the most energetic phenomena in the universe. It spans the range of everything from studying energetic stars and exoplanets around those stars to the most distant universe.
We can start with comets, which are very cold objects. We go then to compact objects where we observe very hot plasma near to the event horizon from a black hole. And then completely different then we look in XMM-Newton data for signature of dark matter. And this, I think, makes this mission so great, that it allows such a broad science to be addressed.
I had a sabbatical in 1982 in the United Kingdom, and my office mate at the time was Steve Kahn. We had a third office mate, was Keith Mason. We came up with the idea that it would be great to do multi-wavelength observations from space, to do deep X-ray imaging and spectroscopy, and simultaneously be able to observe cosmic sources in the ultraviolet and optical bands. If we could do all this from one platform in space, namely XMM, it would be much more efficient. Then when the X-rays saw something pop off, the ultraviolet optical telescope would be right there, seeing it right away.
XMM-Newton is a really fantastic telescope. It's more than just one telescope, actually. You can study the same object across a range of energies, from the optical, where we can observe from the Earth, up into the UV and X-rays, where you really have to go above into space.
It was great to be at the beginning of multi-wavelength astronomy. There's virtually no cosmic sources that just radiate at one frequency. And when you look at the universe with X-ray eyes, you see something much different than when you look at the same universe in ultraviolet eyes.
I led the U.S. piece of one of the three major instruments on XMM-Newton, which was called the reflection grating spectrometer. I developed the initial concept for that in the early 1980s when I was quite young. We knew that many systems in the universe emitted X-rays copiously, but we didn't have very detailed models for how that X-ray emission arises and what it was actually telling us about the systems.
Spectroscopy is the study of light emitted by atoms, but it's more than that because atoms are peculiar. When they shine, they don't just give you all the colors of the rainbow. It looks more like a barcode.
You get very sharp peaks at very particular wavelengths and frequencies, and those are associated with particular quantum states.
It's extremely powerful. It's just like a barcode. It looks like a bunch of garbage to human eyes, but it can tell you, what's in a product and how much it costs and what country it came from and all that stuff.
By measuring that detailed pattern, we can learn about the fundamental physics of what's happening in these very exotic environments, what the temperatures are, the densities, the pressures. The spectroscopy that XMM-Newton did really answered a huge number of questions.
With the most recent result with XMM, we were able to measure the spin of the black hole. And I liked the signal so much so that I put it on a cup and I drink from it every day. So
my son was shocked that other people in the school were knowing XMM-Newton. Small children from 10 years that they know that XMM-Newton is an X-ray satellite.
It was amazing. It's like the Cal Ripken of satellites, of space satellites, this thing that just keeps going and going and going and producing great data.
I'm delighted to see that, number one, the mission is still working, the instrument is still working, and that there are all these young scientists that have been inspired to figure out great things to do with it.
And they're using it in all sorts of ways, which is really amazing to see a telescope used in ways and for discoveries that you could never have predicted when you first were designing it and launching it.
There's certain science that XMM can do that other X-ray observatories can't. Recently, XMM has invested lots of time in these large area multi-wavelength survey fields, including work that I've been leading in a region of the sky that has lots of existing data. And that multi-wavelength data is really important to harness the best scientific results out of XMM.
Astronomy is going through a revolution. There's gravitational waves detected, there's several kinds of weird supernova detected, and having an X-ray instrument to simultaneously operate while these optical instruments are operating would be extremely beneficial.
Many objects change. They have flares and outbursts, so it's really a key observation to have everything from the X-ray, the optical, and the UV all precisely at the same time.
I'm so glad that XMM is a part of that it was taking people originally into the directions of the time, and today is taking people into entirely new directions.
And in that report from NASA TV, we heard from Space Telescope Science Institute astronomer Stephanie Lamassa, ESA XMM-Newton project scientist Norbert Schartel, National Science Foundation Director Franz Cordova, National Science Foundation astronomer Lisa Winter, Stanford Linear Accelerator Center National Accelerator Lab Professor Stephen Kahn, astronomer Maurice Leutenegger from NASA's Goddard Space Flight Center, and MIT Einstein Fellow Duraj Pasham. This is SpaceTime. Still to come, a new deep space dish for the new Norcia ground station, and China launches another spy satellite. All that and more still to come on SpaceTime. The Australian Space Agency and its European counterpart ESA have signed a deal to build a new 35-metre deep space antenna at the European Space Agency's new Norcia ground station. The new $70 million antenna will feature a next-generation antenna feed cryogenically cooled to around minus 263 degrees Celsius, designed to support a 40% increase in data return. Construction should be completed by 2024, with the antenna beginning operations towards the second half of that year. Existing facilities at New Norcia will also be upgraded as part of the project. The new 620-ton parabolic dish antenna will complement the existing 35-metre deep space antenna on the site, 140 kilometres north of Perth. It'll allow additional communications traffic, supporting the growing number of increasingly sophisticated European space exploration missions. These include the existing Mars Express, Gaia, Bepi Colombo and Solar Orbiter missions, as well as the soon-to-be-launched ExoMars rover, Euclid, Hera and JUICE missions. The new dish will also allow greater cross-support on missions flown by other space agencies, such as NASA and JAXA. The new Norcia facility is operated for the European Space Agency by the CSIRO, which also operates NASA's Tidbinbilla Deep Space Communications Complex near Canberra. As well as New Norcia, ESA's S-Track ground station support network includes ground stations at Cerberus in Spain, Milagro in Argentina, Kiruna in Sweden, Kourou in French Guiana, Melinda in Kenya, Redau in Belgium, Svalbard in Norway, and Santa Maria Island in the Azores. This is SpaceTime. Still to come, China launches another military spy satellite. And later in the science report, loneliness associated with an increased risk of cancer. All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
China has launched another military spy satellite as it continues its build-up for what Beijing describes as preparations for war. The Yaogong 34 mission was launched aboard a Long March 4C rocket from the Zhuquan Satellite Launch Center in northwestern China. Beijing describes the spacecraft as a remote sensing satellite designed to survey land resources, urban planning, road network design, crop yield estimation, disaster prevention, and to provide information services for the construction of China's Belt and Road initiatives. In reality, it's actually a 4,200-kilogram military optical reconnaissance satellite, part of a growing constellation of reconnaissance satellites run by China, which now numbers some 76 spacecraft and growing. The payload was successfully placed into a 1,100-kilometre high orbit. The mission was China's 12th orbital launch attempt so far this year, 11 of which have been successful. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study shows that loneliness among middle-aged males is associated with an increased risk of cancer. The findings, reported in the journal Psychiatry Research, warns that loneliness could be as significant a health risk as smoking or being overweight. Researchers say it should therefore be considered an important part of any comprehensive healthcare and disease prevention program. The study, which began in the 1980s, has been following 2,570 men from eastern Finland, finding that 649, or 25% of the participants, have developed a cancer, and 283, or 11%, have died of cancer. Researchers found loneliness increased the risk of cancer by about 10%, and they found the association with the risk of cancer was observed regardless of age, socioeconomic status, lifestyle, sleep quality, depression symptoms, body mass index, or heart disease. They also showed that cancer mortality was higher in cancer patients who were unmarried, who were widowed, or who were divorced at baseline. A new study warns that exposure to poor air quality can impact cognitive performance in older men for up to a month. A report in the journal Nature looked at the mental agility of almost 1,000 American males in a series of cognitive tests and compared their scores with the level of air pollution on the day of each test, as well as across the 28 days before each test. They found higher levels of air pollution in the month preceding a test, even if it was below hazardous levels, was still associated with poorer overall test scores. In quantum mechanics, the Heisenberg uncertainty principle states that the position and speed of an object cannot both be known with unlimited precision at the same time. In other words, you can either know exactly where you are or exactly how fast you're moving, but not both. However, a new report in the journal Science claims researchers have shown that two vibrating drumheads, each about the width of a human hair, can be coerced into a quantum state which evades the uncertainty principle for the first time. In addition to providing a novel technique for evading limitations imposed by the uncertainty principle, the experiment also provides the most direct demonstration of long-lived quantum entanglement between macroscopic objects. In the quantum world, particles like electrons, which power all electrical products, can also behave like waves. As a result, particles can't have well-defined position and momentum simultaneously. For instance, measuring the momentum of a particle leads to a disturbance of position, and therefore the position cannot be precisely defined. Researchers coerce the drumheads into behaving quantum mechanically, vibrating in an opposite phase to each other, so that when one of them is in the end position of the vibration cycle, the other is in the opposite position at the same time. In this state, the quantum uncertainty of the drum's motion is cancelled if the two drums are treated as a single quantum mechanical entity. What all that means is that researchers were able to simultaneously measure both the position and the momentum of the two drumheads, something which shouldn't be possible according to the Heisenberg uncertainty principle. Importantly, the experiment also provided the most solid evidence yet that large objects can exhibit quantum entanglement. Entangled objects cannot be described independently of each other, even though they may have an arbitrarily large spatial separation. Of course, it's not easy to do, otherwise everyone would be doing it. In macroscopic objects, quantum effects like entanglement are very fragile, and they're easily destroyed by any surrounding disturbances. So the experiments needed to be carried out at just 1/100th of a degree above absolute zero, minus 273 degrees Celsius. A new study has found that long-term spaceflight has caused changes in the structure of astronauts' eyes. The findings, reported in the Journal of the American Medical Association, show changes in the eyes of two crew members aboard the International Space Station over the course of a year in space. These included an increase in the thickness of their retinas, as well as a swelling of the optical nerve. However, due to the small number of people studied, the researchers emphasized that they need more participants with year-long missions in order to confirm their observations. Intel launches its new 11th generation Core 8 series processor. With the details, we're joined by technology editor Alex Zaharov-Reut from ITWire.com.
Well, look, the 11th gen Core i9, as it's called, the 11980HK, that's the code for this top-end processor. I mean, that's the best processor they have for laptop and notebook computers. They're saying that on multi-threaded performance compared with the 10th generation equivalent from last year, there's a 19% improvement, and they also say it's got the fastest single-threaded performance of any laptop. They also talk about how it's the best gaming processor, but we're talking about their best processor at probably what is the most expensive price for consumers. They would have Xeon processors and others that cost even more. But those are for real pro computers and data centers and workstations, not the sort of laptop you'll take with you everywhere, be it a thin and light version or one of the gaming ones, thicker and more powerful. But where this compares is that someone like Apple, for example, has their M1 processor. And that M1 processor, based on their launch last year, was able to deliver faster speeds at much lower power usage than Intel's best at the time. I'd be surprised if Intel has been able to match that. I mean, let's not forget, the M1 can operate in Apple's cheapest machines, even without a cooling fan. And if you add a cooling fan in, it can then deliver sustained performance for longer. And those, as I said, those processors are in their most affordable machines that anybody can purchase, whereas this 11th gen will be in quite expensive computers for people who want the best performance. And we don't even yet know what Apple is going to be able to do with the M2 successor to the M1 later this year. So yeah, it's great to see that Intel has sort of gotten off its laurels. It's spent a good 10 plus years on cruise control, delivering much smaller increases in performance. And AMD has been able to really take advantage of Intel's laziness in this regard by really putting the pedal to the metal to get great performance. Has really give Intel a real kit to really give us much more powerful processors, but along has come Apple to eat Intel's lunch and really threaten AMD as well. So look, the consumer is the ultimate winner because we're really seeing competition. And, Intel does claim hundreds of design wins and it does still have the lion's share. But in Apple's latest result, they had massive, I think triple digit, but certainly very high double digit increases in the sales of their Macs and iPads. So, the 2020s is going to be just computing nirvana. And if you need an excuse to buy a new computer, this is a good one.
That's Alex Zaharov-Reut from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.